Hello everyone. In this problem, we are given an array of integers and we have to find pairs of three integers whose sum is 0. Let's get some additional information. First, does the order of the output or the order of the triplet matter? No, anyone is fine. This gives us an excellent way to realize what sort of data structure will we be using. What if we find no triplets? Just return an empty list. Will the question have only one answer? Actually, no, it can have multiple answers. Am I to find three contiguous numbers in the array whose sum is 0? No. Will the array contain any duplicate elements? It might. What are the constraints? Constraints look like these. The length of the array will range between 3 and 3000. The maximum value can be up to 10 raised to 5 and the minimum can be minus 10 raised to 5. To write the code, we are going to use the famous two-pointer approach. The two-pointer approach, as the name suggests, is the one where we use two pointers, left and right. Increment the pointer from the left and decrement it from the right based on some conditions and continue doing that till the two pointers collide. We start with sorting our array. In the sorted array, if the first number is greater than 0 or if the last number is less than 0, we can have no triplets with sum equal to 0. In which case, we just return an empty list. Then we start with skipping the duplicates. Now, the logic behind the core problem goes like this. We have three numbers whose sum is 0. So the sum of the first two will be equal to the negative of the third number, which we have to find. The target will be minus nums of I. We have to now find two numbers whose sum is equal to the target. To do this, we will have two pointers, a left and a right pointer. Unless there are multiple zeros in the list, we will always have negative values that compensate one positive value or vice versa. By this logic, the number that we are looking for will always lie further ahead in the list from the current negative number that we are looking at. This is crucial to reduce the number of iterations while we do the second search. So if the number at the left and the number at the right is less than the target, increment the left pointer. If it is greater than the target, decrement the right pointer. If it is equal to, then add the three values found at I, left and right to the results after checking if the last entry was the same. If it was, just skip that part. Again, here we increment the left pointer and decrement the right pointer. And in the end, we just return the results and voila, there we have it. Coming to the time complexity of the problem, we first sort the array. So the time complexity for sorting is O of n log n. And along with that, every time we have a new target element for each iteration, which compares again for approximately n times, it does decrease as we go further in the array. But for simplicity, right now, we are going to consider n times. So that will be O of n and O of n multiplied. So O of n square will be the time complexity because O of n square trumps O of n log n. The space complexity will be O of n and the size of the output can vary. If we consider the maximum size of the array, which is 3000 elements, and if we take a tight bound range of minus 1500 to 1500, we get the maximum value of triplets that we can possibly have, which is 1124250, and it is almost 375 times of n. This is the worst space complexity we have. The average triplets, when we consider all values from minus 10 raised to 5 to 10 raised to 5, are in the range of 17,000, which is close to 6n and can be considered as the average space complexity. Okay, that was it for the three-sum problem. I hope you find the pairs that keep you good company. With that, spreading lots of love and keep learning more algorithms. For more amazing videos from my end, subscribe to my channel and like my video.